Hi, and welcome to this STAIR Tailored. I'm Erica Mason from the University of Missouri. Today you're watching part 4 of a 5-part series about what it looks like to factor quadratic expressions. And today's video is specifically about how to help students use the box method, which is a graphic organizer, to help them transition from using concrete and pictorial representations and moving on to more abstract notation. Before we get started, let's talk a little bit about those terms I just mentioned: concrete, pictorial, and abstract. So those are really the 3 primary types of representations that we would encourage all students to develop proficiency in so that they can approach mathematics in really flexible and dynamic ways. This is especially important for students with mathematics difficulty or disabilities because we really want to equip those students with a range of tools that they can use to approach any mathematics problem. It's reasonable to know that students who have all 3 of these representational tools in their toolbox will be able to choose which one they want to use depending upon the problem. We should note 2 things about this problem before we get started. First, at this point, you would present this problem to students who had already discovered the rule for factoring expressions, which broadly states that the constant term of both of the factors should sum to be the linear term, and it should also be able to be multiplied to create the constant term. If students understand that rule, then they'll be able to approach this problem in a really flexible and meaningful way. This example comes from an article by Tricia Strickland in which she encourages teachers to introduce the box method, but to have the quadratic term and the constant term already put in place. So now students are just left to reason about what these factors might be by considering what they know about this constant term, -24. So students are going to ask themselves, what factor pairs can I multiply to get 24? So we're first going to start by really just considering what are the factors of 24, and we'll attend to that negative sign in just a minute. I should also say before I get too far in that this problem really represents a more complex problem because there are lots of negative terms. Students should absolutely be given the opportunity to approach this problem and try it and grapple with it, but expect that this might be a real challenge to them, especially if they're used to finding factors of expressions of only positive terms. So, okay, what are the factors of 24? We have 1 times 24. We have 2 and 12. We have 3 and 8, and we have 4 and 6. Now that we've got these factor pairs, we can really attend now to this linear term. So we need to find 2 factor pairs, and you can think of this in either way. You can think which 2 factor pairs sum to -2, or which 2 factor pairs result in the difference of 2, right? So whichever way it makes sense for you to think about. So we look at 1 and 24, and if I'm thinking about it in terms of do they sum to -2, that would be no. What about 12 and 2? The difference there is 10, and so it can't sum to -2. Again, 3 and 8, I have that same consideration, and so I eventually end up with the 2 factors 4 and 6. But now I need to attend to where my negative sign comes in, because I need this linear term to be negative, and I also need the constant term to be negative. So I know when I come over to my table that in order to get this x squared, that I'm going to multiply x times x. Now when I'm thinking about this term here, I'm going to include the sign and the term. And so I'm going to let's try -4 and 6. And let's see if that makes sense. So if I'm trying to see if -4 and 6 sum to -2, I would say that -4 plus 6 is +2. So that doesn't work. -4 times 6 does still have the product of -24, so it works in that way. But it doesn't quite work for our linear term, and that's okay. So again, this might prompt students to then change the signs and try another one. Okay, so what happens if I change this to a +4 and a -6? If I'm trying to sum to -2, if I have 4 plus a -6, do I get a -2? I do. And again, this still holds true for this integer constant in that 4 times -6 is -24. So then I can go ahead and fill in my other parts of the box. So now I have x times 4, which is 4x. And then I have negative 6 times x, which is negative 6x. Once you've finished using the box method, you can now rewrite the factors in more standard form. So you have the expression x squared minus 2x minus 24 equals, let's see, x plus 4 times x minus 6. Thanks for watching this Stair Tailored. Make sure to check out the last video in this series in which we encourage and teach students how to see the equivalency between the quadratic expression and its factored form.